Hello everyone, it's Mr. Wolfe here, and in this video I am going to be introducing motion maps. And so what motion maps are is it's a way to model the motion of an object, and specifically looking at the interaction maybe between velocity and acceleration and where that object is at a certain point in time. So what a motion map is imagine that you have a car that's driving and at every second, so like maybe this is 1 second, 2 seconds, 3 seconds, 4 seconds, at every second, the car is maybe leaking a little bit of oil and it drips on the ground. So the question is after that car's gone, what would that oil look like? So here, let's say our car's just going at a constant speed. So at 1 second, maybe the oil's right there. The oil's right here at 2 seconds, 3 seconds, and 4 seconds. So there's an equal distance in between each spot. And so this would be an object going at a constant speed. Right? So I could do the same thing down here for this car. So a faster constant velocity to the right. So if I draw my motion map, I draw a dot, and a dot for where that car would be. Right? Now something to notice is that both were going at a constant speed, so you have an equal distance between them. But since this one's going faster, there's a greater distance in between each dot. And that makes sense because the car's traveled further in the same amount of time. All right, now there's other things I could do. So if I look at this map and I don't have the car, well, was the object going to the right or was the object going to the left? Right? And so I could represent that with a velocity arrow. And we usually will draw our velocity arrows in red. Right? And so in this case, if I go up here to draw my velocity arrows, well, my car's going to the right based on the wind that I see right here. So I'm going to draw an arrow. And notice that I'm drawing the arrows the exact same length. And I could even show that I'm trying to do that by drawing this congruent arrow right here. All right. Now, how would I model the one below? Well, it's going at a faster constant speed, so I'm going to represent that by drawing a larger size arrow. All right. Since it's going at a constant speed, I'm still going to draw these arrows the same size, so I'm still going to make that congruent line, but they're just bigger than they were before. All right. Well, what about my acceleration arrows? All right, well, since I'm going at a constant speed, I don't have an acceleration in this instance or in this instance, so I'm not going to draw anything for acceleration. Now let's look at another example. All right. So let's say I have an object going to the right and speeding up. So I'm going to first start drawing my dot. And then I'll say, well, all right, if it's going to the right, maybe after, and you don't have to do this each time, but I'm going to do it for the beginning, maybe after 2 seconds, it's made it this far. And maybe after 3 seconds, it's made it a little bit further because it's speeding up, right? And then maybe after 4 seconds, it's even gone further. Right? So notice that my distance is different between them. So the next thing I need to do now is, just like I did before, is I'm going to show the direction of this object. I'm going to say, okay, well, it was initially going to the right. And since it's speeding up, I'm going to draw these arrows getting bigger each time. And remember, the red represents my velocity. All right. And I'm not going to draw any congruent arrows because these arrows are different. So the next thing we need to do now is I'm speeding up, which means I'm changing my velocity. Remember, acceleration literally means a change in velocity, so how am I going to represent that? I'm going to represent my acceleration, and you could always read the rules right here, with blue arrows. Right? And we're going to learn in Unit 2 that acceleration, so acceleration, the definition that we know now is it's a change in velocity. But we're going to learn in Unit 2 that the acceleration is a result of a push. All right? So think about, the acceleration is not the push, but it's the result of a push. So if I have an object that's speeding up, think about what direction that push would be going. Right? If I'm speeding up, that push is going to be going in the same direction that I'm going to be speeding up in. So above my line, I'm going to draw these blue acceleration arrows. Right? Now, one thing to notice, these acceleration arrows are all the same. Right? So the rate at which velocity is changing over time is the same. That's the acceleration. But my velocity is changing. All right. So let's say I have an object moving left at a constant velocity. Let's see. I got my car right here, right here, right here. You're not always going to get these cars, right? Like for instance in this example, but in this case we do. And I'm going to have to show that it's going to the left, so I'm going to draw my velocity arrows going to the left. All right. And notice that maybe this arrow might be a little bit longer, but just to convince the person that's looking at my model, I'm going to say that, hey, these are going to be going in the, this is going at a constant velocity, so I'm going to draw these congruent arrows. All right, do I need to draw acceleration arrows with a blue pen? No, because I'm going at a constant velocity. There's no acceleration arrow, so I don't draw anything else. Right? You only draw acceleration if we're changing velocity. So speaking of changing velocity, I could be increasing my speed, right, by speeding up, or I could be slowing down. Right? So that would be acceleration as well. So let's look at this example. Moving to the left, so I'm going to start over here, and it looks like it's slowing down. So initially my object was probably going pretty fast, and then as time went on, it starts to slow down, so it's covering less distance over time. So I could represent my velocity with my red pen, and as time goes on, my velocity gets smaller and smaller, and I might not even draw velocity here. Maybe it was actually at rest at this point. All right, so then we have to think, well, which way? We know we have to draw our acceleration arrows here because we are changing velocity. We have acceleration. The question is, well, which way do we draw it? Remember, acceleration is going to be the result of a push, so we can, if something's moving this way and it's slowing down, well, that's probably because there's a push going in the opposite direction, right? And so that result of the push, the acceleration, is going to be going against that velocity to slow it down. Right? Now, just like we did before, and in all our scenarios in physics, is that these acceleration arrows are going to be the same length. And it's that acceleration that causes this velocity to change, specifically in this instance, for an object traveling to the left to slow down. So this is a quick introduction on motion maps. Thanks for watching.